We were looking at this arithmetic sequence, 2, 5, 8, 11, 14, 17, and we talked about how we define this sequence. Now, we really only need two things to define it. We need the starting number, and we call that A, and we need our common difference, D, and that was 3. And basically from these two numbers, we would be able to theoretically generate the whole sequence as long as we need it to. So if I needed 100 terms, I could keep adding 3 until I had 100 terms. Okay, these two pieces of information are actually all that I need. Problem is, if I wanted to get what the 100th term was, okay, if I'm asking what T100 is, that is going to be a really long and difficult process to go through. I don't want to have to keep adding 3 until I've done it 100 times. I mean, you could conceivably do it for 100, but it's going to be harder if you wanted to go up to 1,000 or to 1,000,000 or something like that. So what we're looking for is there a shortcut method? Is there a way that I can get from this information up to the 100th term without having to do 100 terms across my page? Okay, we want to get there in one step. And to do this, I'm going to think about how these things are calculated. Okay, so I'm going to write down, to start off, I'm going to write down my terms. And I'm going to do what any good mathematician would do and look for some patterns. Okay, term 1, that was A, or just 2. Term 2, that's going to be 5, 8, 11, 14. These were the terms of my sequence, term 1, 2, 3, 4. And we're going to look at our patterns of how we got these. So, and what I'm actually going to do is I'm going to break them down into how we calculated. So T1, that was just 2, that's where we're starting. T2, I got that number 5 by taking my original term and adding 3 to it. Okay, which was my common difference. To get term 3, I took the previous term, number 5, and added 3 to that. But you can think about term 5. We got term 5 by doing my original number plus 3, and then to get the 8, I'm adding 3 on it again. Similarly, the next term, I started with 2, and I added 3 to get 5, and then I added 3 to get to 8, and then I added 3 and I get to 11. And you can sort of see what I'm doing here. Any particular number in the sequence was essentially calculated by taking the 2, the starting number, and adding a bunch of 3s on, depending on what term. And what I want to think about is how many of these 3s are there. Okay. In this term, term 2, I've added 1 3 on. In the third term, I've added 2 3s on. In the fourth term, I've added 3 3s, and so on. And what I'm going to look for is a link between the number of 3s that I've added on and the number of the term. And if we compare those two things, it's pretty easy to see that the number of 3s that we're adding on is 1 less than the number of the term. Okay? The number of 3s that we had to add on to get to that number is 1 less than the number of terms. So where does that leave us? Okay? What I want to do is I want to rewrite this without thinking about this particular sequence that we're working with up here. I want to look at this more generally. So what I'm going to do is I'm going to think, okay, term 1, that was equal to 2, and the reason it's 2 is that's our first term. So term 1 is always the same as A. That's fair enough. Term 2, how did I find that? Well, I went my A, 2, and I added on the common difference, D. To get term 3, I started with A, and I did plus the common difference, plus the common difference again. The fourth term, I did the common difference plus the common difference plus the common difference again. Term 5a, and I'm going to add the common difference 4 times. Okay. Now, if we have a look at this, and we look at the patterns here, we've got some algebra. It's a good idea to tidy up this kind of algebra when we see it. Okay, the first two don't really tidy up, but the next one we can use our algebra laws to simplify this. We've got two like terms here, d plus d, that's equal to 2d. So I'm going to write that as a plus 2d. This one here, 1, 2, 3 of them, so it's a plus 3d. This one here is a plus 4d. Okay. Now we've already noticed that the number here, the number of d's that we're adding together, is 1 less than the number of the term. That's why it's a 3d and it's term 4, a 4d and it's term 5. So the question that I started with was, what's the 100th term? Well, the 100th term, it's just going to be a plus 1 less than 100 is 99d. Okay. So what I can do in this particular case, my a was 2 and my d was 3. So we're going to go that the term 100 is going to be a was 2 plus 99 times 3. And that, 99 times 3 is 297. And adding those together, I'm going to get 299 is going to be my 100th term in this sequence. Now, the fact that I could work that out is really powerful. Okay, because I was able to notice this pattern about how the terms were calculated, I was able to go straight to term 100 and I didn't have to calculate all the terms that came before it. Now, similarly, if I wanted to find out term, say, 1500, that would be pretty easy too. I can use the same idea. It's going to be a plus 1 less than this is 1499 times d. I'm not going to work that out. I would do it like this. A is 2, d is 3, and then I could calculate that. It'd be some really big number. Okay, I'm not so concerned about what that is. But the point is I can find any number any numbered term that I like in this sequence without having to calculate the whole sequence before it. I'm just going to do one more short video on this, and we're going to look at this result and we're going to generalize it a little bit using algebra.